Washington, D.C., United States, 16th of January, 1942. Before dawn, a new office glowed above Constitution Avenue. Engine plants from Detroit to Lynn sat idle for lack of bearings, copper, and machine tools. Pilots waited on cold runways. One order, signed this morning, promised to turn scarcity into flow and keep engines coming without stoppages. Executive Order 9024 named Donald M. Nelson to set priorities and schedules under the War Production Board, WPB, a central authority for war industry. Until now, factories chased parts through overlapping requests and shifting quotas. No engines meant grounded bombers and empty training fields. The WPB could decide who got copper on Monday and machine time on Friday, then enforce it. One decision would align metals, parts, and time across the nation, and push production toward 100,000 aircraft engines without missing a beat. 15th of November, 1941, East Hartford, Connecticut, United States. A line of Pratt & Whitney engines stood still, while a foreman counted empty bins. The missing piece was a magneto, a self-powered ignition unit for piston engines. Every halted stand meant pilots waited and trainers sat on ramps. The fix would not be one more rush order, it would be a system. By late 1941, overlapping offices, the Office of Production Management, OPM, and the Supply Priorities and Allocations Board, SPAB, sent factories conflicting directives. Pratt & Whitney in East Hartford, Wright in Patterson, and Allison in Indianapolis competed for the same copper and steel. A bill of materials, a complete parts list for one finished product, ran to thousands of items per engine. One absent fastener or gasket could stop an assembly worth weeks of work. Machine tools, not labor, set the first ceiling. A machine tool, a power-driven metal cutting or shaping machine, determined how many cylinders, cases, and gears could be cut in a day. In Cleveland, foundries prioritized local contracts. Aircraft orders waited behind automobile die sets. Aluminum forgings, shaped metal formed by compressive force while hot, and bearing steel arrived late, and inventories whipsawed week to week. At an East Hartford dock, a flatbed carried copper bar for windings and bus bars. The driver would not unload. The invoice listed an Army priority, and a Navy letter arrived second with different instructions. Purchasers waved forms stamped urgent, but the mill refused to honor both. The bar sat, unpaid and unusable, while assemblers cannibalized yesterday's scrap. Detroit's tool rooms built duplicate jigs, a fixture that holds parts in place for machining, for similar engine mounts because no one pooled designs. Each jig consumed scarce tool steel and skilled hours. The Army and Navy wrote different specification, spec, a documented technical requirement, for the same fastener diameter, splitting capacity between near-identical bolts. Suppliers raised bids to hedge risk, prime contractors hoarded stock, deliveries slipped out of sequence. Without a single calendar, factories scheduled on hunches and rumors. Gauges went missing. A gauge inspection, a precision tool that verifies part dimensions, could hold up an entire line when it did not arrive with the parts it measured. Night shifts idled for want of inspection pieces, even as day shifts piled subassemblies. Acceptance test, final run verifying performance before delivery, slots backed up like traffic at a narrow bridge. Training commands expanded faster than engines shipped. New airframes filled hangars, wings draped with canvas, waiting on power plants still in crates. A single absent $5 valve could hold a $25,000 engine on a cart, half-plumbed and already spoken for by a squadron. The shop floor called them nearlies, and there were more almost finished engines than accepted ones on the test stands. procurement officers issued rush orders that collided at the same mill gate. Two buyers arrived within hours for the same heat of bearing steel, each with a priority letter. Plants wrote their own priorities when a telegram lagged. Mills ignored them when another letter with a higher number arrived. No one owned the master ledger that matched metal supply to engine-by-engine needs. The acceptance bottleneck grew for reasons beyond mechanics. Test fuel shipments came late or arrived as the wrong grade, and instrumentation kits split across rail cars. A gauge package meant for Indianapolis turned up in Patterson, and vice versa. Engines waited for instruments to measure oil pressure and temperatures that would certify them fit to fly. Managers knew the work. They could quote torque values and set clearances from memory. What they lacked was a single traffic light to govern who stepped on the gas and who braked, hour by hour, across a continent of shops. Until then, the loudest plants still sounded like this, noisy, skilled, and slowed by the smallest missing part. A clerk slid a single page across Donald M. Nelson's desk. The header read Executive Order 9024. The stakes were plain: engines stalled on stands, pilots grounded, factories burning time with nothing to cut. The order created the War Production Board with power to allocate materials and set priorities. Nelson, a former Sears executive and head of the Office of Production Management, took the chair. His mandate was blunt: unify schedules, allocate metals, standardize orders, and conserve capacity. Authority meant little unless he could turn it into coordination. He started by closing valves. A limitation order, a WPB rule that restricted civilian use of materials, froze non-essential aluminum and copper goods. New cookware, toasters, and decorative hardware stopped at once. Those metals moved to aircraft and engines before everything else. He then abolished the maze of overlapping letters and stamps that plants had waved at mills. A single priority rating, a code that moves an order to the front of a queue, replaced them. If a shipment had the code, it moved. If it did not, it waited. In Cleveland, a mill foreman watched the first WPB stamped request hit his desk. Yesterday, he juggled Army and Navy letters with local promises. Today, he had one code he could not overrule. He stamped coil tags, rerouted a heat of copper, and told a home appliance buyer to come back next quarter. The foreman did not have to like it. He only had to obey it. Nelson built an organization to match the scope of the problem. The board absorbed OPM functions, so the same office that wrote schedules could assign the metal to meet them. Industry divisions mirrored the nation's shop floors. Aircraft engines sat under a dedicated unit with direct liaisons at steel, copper, and aluminum mills. A central requirements committee mapped each engine bill of materials to quarterly metal quotas. A quota, a fixed allotment of material for a period, turned tonnage into calendar entries. Field offices opened in Pittsburgh, Cleveland, Detroit, and along the aluminum smelter belt. Their job was simple: police compliance and keep the numbers honest. The board needed a shared clock. It launched the Production Requirements Plan, a plant schedule tied to material issues, to collect factory-by-factory needs on one calendar. Every cylinder, case, gear, and magneto sat on a dated line. Shipments left mills against those dates, not against whoever shouted loudest. The plan ran forward from the test stand. If final acceptance needed 10 magnetos a day, the chart forced upstream orders for wire, insulation, and brackets to land in sequence. This made capacity constraints visible days ahead, not hours late. Technical alignment had to follow the calendar. WPB recruited panels from Pratt and Whitney, Wright, and Allison to rationalize specifications. Where fastener diameters matched in function, the committee wrote a single spec. Where gauges differed by minor detail, they chose one. Eliminating duplicates let the board pool orders for bolts, bearings, and gauges across engine lines. A bearing shop could now cut one race profile for 3 customers, then run around the clock. That meant fewer setups, less scrap, and steadier deliveries. Nelson also claimed the right to change the part, not just the line. Substitution, approved swap of materials or parts with equal function, moved from suggestion to policy. If bronze bushings could replace a scarce aluminum-bronze alloy without loss, WPB could compel the switch. If 2 magneto suppliers met the same performance, the code sent work to the one with metal on hand. His rule was explicit. No engine plant should idle for a missing small part if a substitute could run. That freed nickel, chromium, and other critical alloys for where they were irreplaceable, like turbine blades and high-stress valve seats. The public saw the effect in store windows. Limitation orders throttled civilian refrigerators, toasters, and non-essential metal goods within weeks. Retailers boxed stock for transfer. Aluminum cookware turn-ins, paired with frozen inventories, funded aircraft sheet supply for the first quarter. The scrap alone did not move mountains, but it covered the early schedule while smelters shifted feed and rolling mills changed dies. That kept wing skins and crankcase halves on plan while new capacity came online. Machine tools were the next gate. The board wrote a short list of who got them first. Engine lines took precedence over airframes, which in turn came ahead of ordnance where another machine could often do the job. New grinders, hobbing machines, and jig borers landed where they would free the most horsepower per hour. To prevent a $1,000 part from stopping a $25,000 engine, WPB published a national do-not-break list. Magnetos, bearings, and piston rings, a sealing band around an engine piston, sat at the top. Those items could not be delayed by any lower-rated request, no matter how local the pressure. This system centralized more than metal. It centralized the calendar itself. The priority code on an order matched a date on the PRP chart and a line on a mill rolling schedule. The Cleveland foreman saw trucks leaving on time, bound for engine plants whose test stands stayed hot. The factory floor felt the difference in what did not happen. Fewer nearlies, fewer cannibalized subassemblies, fewer night shifts idled by a missing gauge. Managers still quoted torque values and clearances from memory. Now they also opened the same schedule and saw the same week. By spring, the board had something like a national production rhythm. Decisions in Washington translated into castings in Indianapolis and forgings in Patterson without the old crossfire of letters. The authority of Executive Order 9024 had become a machine with gears, limitation orders to conserve, priority ratings to sequence, quotas to allocate, and a plan to tie it together. The next measure was speed. Could the calendar absorb a surge and a new engine variant without a single stand going dark? The Patterson foreman dragged a ladder to the wall and lifted a slate. He drew a grid and wrote dates in red chalk, one for each compressor case and magneto due that week. The board showed what mattered, which day each supplier delivered, and which day a test stand lit. If the dates held, engines flowed. If they slipped, pilots waited. Engine programs carried top-tier ratings and suppliers saw unambiguous sequences. The War Production Board posted expediters, a person who accelerates delayed orders through a process, inside key plants. They walked orders through heat-treat pits and inspection rooms before trouble turned into idle stands. When a valve spring shipment lagged in Cleveland, the expediter moved it to the front and put the next melt on the calendar. The Production Requirements Plan, PRP, ran deeper than due dates. It matched metal melts to machining cycles and heat treat capacity. Heat treat, controlled heating and cooling that hardens metal, could not be booked by guesswork. The schedule counted furnace hours, quench tanks, and draw times against actual loads. A crankshaft forging that soaked on Tuesday met a grinder with a free spindle on Thursday and a test cell on Monday. Then came the Controlled Materials Plan, CMP, a system that rationed steel, copper, aluminum. Instead of pleas, each engine program received fixed percentages by quarter. CMP converted promises into arithmetic, tons in equaled engines out by quarter. If the PRP called for 5,000 tons of alloy steel, the CMP wrote the vouchers and the mills rolled heat numbers against them. The vague, as soon as possible became week 12, ingot 47, billet 19. WPB pressed the parts that many engines shared. It prioritized shared components across models to reduce changeovers, time lost switching tools between parts, standardized magnetos and carburetors, a device that mixes air and fuel for combustion, cut part numbers and eased spares. Limitation orders forced redesigns to use abundant alloys where performance allowed. Where nickel bronze had been habit, manganese bronze carried the load, and the schedule never noticed. Bearings showed the shift. Chromalloy allocations to bearing makers arrived steady, not in bursts, and piston ring sets appeared on time. Engine tests ceased failing for lack of rings. A bad run meant a fix in metallurgy, not a missing box. WPB also scheduled inspection gauges centrally. Acceptance testing stopped being the choke point because the right gauges arrived with the parts they measured. A shared critical path, the longest chain of tasks that sets total time, identified the bottlenecks, and mills planned melts to feed those points first. Tools moved too. A $200,000 machine tool pool traveled by rail to whichever engine plant was ready. When Patterson finished foundations ahead of schedule, carloads of jig borers and gear hobs arrived under seal and went on the floor the next morning. The board's power to preempt carriage space kept parts moving on rail even during coal shortages. What if a hurricane hit a Gulf copper refinery? Backup quotas stood ready, and the plan diverted cathode from inland smelters before any line went dark. Subcontracting widened under prime oversight. Small shops took valve guides, a sleeve that stabilizes a poppet valve stem, and pump housings while the primes held the hard cores and cases. WPB's capacity surveys found underused night shifts in tool rooms and grinders from Chicago to Los Angeles. It moved rated orders to fill them, and the night whistle in towns that had never built aircraft parts began to blow. The rated flow made future deliveries predictable, so suppliers stopped hoarding and started shipping to the day. Standardized specs reduced rework. Gauges matched the drawings, no matter whether the part came from Indianapolis or Lynn, and inspection no longer sent pallets back for a tenth of a thousandth. The PRP kept those winds from scattering. It tied bearings and bolts to the same rhythm as castings and cases. The Patterson board in red chalk told the truth each morning, and the truth was simple. Lines ran continuously. Starts and stops gave way to cadence. By late 1943, the flow settled into a steady beat. Over 100,000 aircraft engines moved from stands to crates without a single prolonged stoppage traced to materials. Acceptance testing, once the choke point, matched assembly outputs week by week. The piles of almost finished engines thinned until they were exceptions, not the rule. In Indianapolis, Allison's test stands ran day and night with no parts gaps between runs. Operators rotated. The engines did not. Magnetos arrived when the calendar said they would, and so did valve springs, rings, and gauges. The noise that mattered was combustion, not phones demanding rush shipments. Inventory days at the big engine plants flattened. The whipsaw of feast or famine bins gave way to level shelves, counted against the same national clock. Railroads billed fewer hot shots, and rush premiums on freight declined because rated carloads left on schedule. Air freight, once a crutch for late parts, returned to edge cases instead of routine. Unplanned overtime fell as changeovers and spec conflicts receded. Long runs of standardized parts kept grinders spinning without the lost hours of teardown and setup. Tool rooms loaded fixtures once and ran them for weeks. The system was not glamorous. It was predictable, and predictability built volume. Field units felt the change in maintenance, not just deliveries. Spares traveled in the same rhythm as new engines, bundled in packs that mirrored factory usage rates. Cannibalization, removing parts from one unit to fix another, dropped because the parts carts arrived before shortages turned into raids on parked aircraft. Training fields kept hours up. Line squadrons kept aircraft on strength without stripping hangar queens. The method worked because the calendar, not price, governed scarce inputs. Centralized authority ended bidding wars that had stranded parts at the wrong mill or on the wrong dock. WPB's plant-by-plant schedules turned small suppliers into cogs of a national machine. A shop that cut valve guides in Peoria or fuel pump gears in Oakland no longer guessed. It held a rating, a date, and an alternate assignment on paper if a mill or furnace went down. Risk management matured from improvisation to policy. Alternates for mills, alloys, and part sources stood ready in files before disruptions hit. When a rolling mill stopped for maintenance, the voucher already named the second mill and the week to ship. Substitutions moved from art to checklist. The same calendar that sequenced deliveries also mapped detours. The board measured throughput, not promises. Quarterly quotas shifted on data, not pleas, and the shifts were visible across every schedule tied to them. The revealing fact sat in weekly exception sheets. Engine downtime for missing parts fell to noise-level blips on the reports, lost among routine maintenance and test rework. Assembly and acceptance converged. Daily run logs matched to within the same week because the gauges, the fuel, and the instrument kits arrived with the engines they were meant to certify. The lesson outlasted the war. Modern mobilizations still copy the WPB triad, three interlocking control tools used together, of priorities, allocation, and scheduling. Priorities set the sequence. Allocation assigns the metal, scheduling ties both to time and place. It is a plain design. It holds because it turns scarcity into coordinated motion. Executive Order 9024 was the hinge. Before it, noise. After it, cadence. Engines reached flight lines in step with training and with airframes leaving final assembly. Crews met shipments they could plan against, and factories ran to a beat that outlived the crisis that created it. The arc closed where it began. One office, one calendar, one unbroken flow. Back in that lit office over Constitution Avenue, the first priority code left the desk and the line began to move. Engines followed because materials, time, and attention were forced into alignment, not left to bids or guesses. More than 100,000 power plants cleared stands, letting bombers keep training cycles and fighters meet deployment dates. The mechanism was simple on paper: priorities, allocation, and scheduling, yet hard in practice until it became habit. Executive Order 9024 still reads like a wiring diagram for flow. The glow in Washington marked the moment a single calendar replaced noise, and the nation's engines ran without missing a beat.